And here we are, the last section that we're covering in Chapter 7. So 7e is about counting and probability, but mainly we're going to focus on the counting part. First rule I want to give you is how to count arrangements with repetition. Okay, that's important. So here's the idea. If I'm going to make R selections from a group of n choices, then I have a total of n times n times n, and this is n times n, R times. That's how many different arrangements there are. All right, so this is with repetition. That's the important thing to remember. This isn't as complicated as that formula and this description makes it sound, okay? Just look at this. How many 7-number license plates are possible? Well, as is shown in this picture right here, for the first number, there are 10 choices. For the second number, there are 10 choices. For the third number, there are 10 choices because we can choose the same number over and over and over. So how many 7-number license plates are there? Well, 10 choices for the first, times 10 for the second, times 10 for the third, times 10 for the fourth, times 10 for the fifth, sixth, and for the seventh. So let me make sure I wrote the right number down. 1, 2, 3, 4, 5, 6, 7. Yeah. So that's 10 to the 7. So there are 10 to the 7 choices. Or another way to say it is there are 10 million different possible license plates where the restrictions on them are, they have to be a number. Okay, let's do a similar question. How many possible license plates are there? But now they're going to consist of 3 letters. That's the first change. They're going to start out with 3 letters followed by 4 digits. Well, we do this in a really similar way. All we have to do is just keep track of our choices and count our choices. So first, we have to choose the first letter, and then the second letter, and we're going to multiply those two choices together. The third letter times the first digit, the second digit, the third digit, and the fourth digit. So times, times, times. This is going to be a digit, and here, and here, and here. Well, how many choices do we have for that first letter? 26. Second letter, since this is with repetition, 26. Third letter, 26. And so for the next, we have digits to choose from, 0 through 9. So we have 10 choices, 10 choices, 10 choices, and 10 choices. So in other words, we have 26 to the third power times 10 to the fourth power, which works out to be 175,760,000. So that's how many license plates there are that are 3 letters followed by 4 digits if repetition is allowed. All right, and the other kind of counting we need to do are things that are called permutations. So and this is important, you need to be aware of what a permutation is. We're dealing with a permutation whenever all selections come from a single group of items. Nothing can be chosen more than once. In other words, this is one of the things that differentiates it from what we had just did. So this is without repetition. And finally, the most important thing to remember when you're doing permutations is that the order of the arrangement matters. That's the most important thing about permutations. The order of the arrangement matters. So, for example, ABCD is a different permutation from DCBA because the order that you write those letters in matters. Those are different permutations. Okay. Now, this formula makes it look more complicated than it is. But the total number of permutations possible with a group of items is n factorial, which is n times n minus 1, and the 2 times to 1. So in other words, here's a quick example. 3 factorial is 3 times 2 times 1, which works out to be 6. Okay. Uh, 4 factorial is 4 times 3 times 2 times 1, which, 4 times 3 is 12, times 2 is 24. That's what factorial is. Let's look at a few examples. So let's suppose that some middle school principal has to schedule 6 different classes, an algebra, an English, a history, a Spanish, a science, and a gym class, and 6 different time periods. How many different class schedules are possible? Well, notice 2 things. Notice, first of all, that there is no repetition. It wouldn't make sense to schedule 2 English classes because there's only one English class that the middle school principal needs to schedule. So there's no repetition here. The second thing is the order matters because having, say, algebra first and English second is a different schedule from having English first and algebra second. So these 2 things tell us this is a permutation problem. So again, just keep track of your choices. Okay, we're scheduling 6 different classes, so I'm going to draw 6 different sets of parentheses, and all these numbers get multiplied together. 1, 2, 3, yeah. So how many choices for the first class? There's 6. Now one of those classes is gone. Suppose he picked, say, gym to go first. I remember when I was in middle school, one year I did have gym first, early in the morning, and those were not fun days. But now if one of them's gone, there are only 5 choices next. So maybe he picked history next, and now there are only 4, and then 3, and then 2, and all that's left is to have English last. Save the worst for last. So this happens to be 6 factorial. And that's always going to happen. You're always going to get the factorial if you have 6 items and you're making 6 choices. Also, this works out to be 720. So there's 720 possible schedules. Now let's look at an example of what happens when you're doing this type of thing, but you're not choosing all of them. Okay, so in this example, there is a team that has 10 different swimmers on it, and we want to figure out how many possible 4-person relay teams there are. Well, once again, this is without repetition. In a relay, the same person isn't going to swim twice, and the order matters. Having the girl with blonde hair go first and the girl with black hair go second is different from having the girl with black hair go first and the girl with blonde hair go second. So order matters, no repetition. This is a permutation problem. But notice I'm not using all 10 of my swimmers. So how do you do this question? How do you do this problem? You do it the exact same way. For the first choice, and it's even written right there are 10 choices. See, there are 10 choices first. And then for the second place, there are 9 choices, and then 8 choices, and then 7 choices, and we stop. Because this is all 1, 2, 3, 4 possible people to be on the relay team. So there are 10 times 9 times 8 times 7, or 5,040 possible relay teams. So this is, really similar to the problem we just did. However, we don't go all the way down. We don't do 10 factorial. We only count 1, 2, 3, 4 choices because we're only choosing 4 people out of the 10. And our last example is pretty similar. Some international track event has 8 athletes participating, and it's giving out 3 medals, a gold, a silver, and a bronze to be awarded. How many possible orderings are there of the top 3 athletes? Well, so we're choosing, so we have 8 athletes, and we're going to take 3 of them to win the gold, the silver, and the bronze. No repetition, because the same athlete can't win 2 different medals. And order matters, because, athlete 1 winning the gold is different from athlete 2 winning the gold. So no repetition, order matters. This is a permutation problem. Well, I have gold. I want to count how many choices I have for the gold, how many choices I have for the silver, and how many choices I have for the bronze. I have 8 choices for the gold. 8 different people can win it. Once one of those people has gold, that leaves 7 more people for the silver, which leaves 6 more people for the bronze. So 8 times 7 times 6 is 336. So there are 336 different orderings. And that is it for this section.